Hi, welcome to this lesson on analytical geometry, tangents to circles, part 2. Let's have a look at question 3. We're given a circle here that has a center of -4, 2, and it passes through the points P, which is 2, -3, and Q, which is -10P. Okay, find the equation of the circle given. Okay, so first of all, it's going to be of the form x minus h all squared plus y minus k all squared equals r squared. And in this case, the center was given, so it's going to be x plus 4 squared plus y minus 2 all squared. So always the opposite sign of here, equals r squared. And again, I can find the value of my r because I know 2 points for definite, which is here. And in that right angle triangle, so from -4 to 2, that is 6 units across. And then from 2 down to -3, that is 5 units vertically. So therefore, that's the r value. So my radius, r squared, is going to be equal to 5 squared plus 6 squared by the Pythagorean theorem, which is 25 plus 36, which is 61. So therefore, r squared is 61. Therefore, I can replace that. So it's x plus 4 squared plus y minus 2 squared equals 61. And that is the equation of this given circle. Next, they want us to determine the value of P. So P is this y value, right? And that y value belongs to that coordinate Q. So now, just from a geometrical standpoint, it almost looks like these two are in line with each other, right? And this being the center, we know theorems about circles that go through the center to a line if it's perpendicular and it bisects it, right? We know theorems like that, but that might not necessarily help us here. So what we're going to do is we're going to use the equation of the circle and find the possible values of P. So notice that what we're going to do is we're going to substitute the point Q, -10P, into the equation, which was x plus 4 all squared plus y minus 2 all squared equals 61. Now notice you're going to substitute x as -10 and p as y. So when you put -10, you're going to expect algebraically 2 answers, and geometrically there will be a third point r with the same x value of -10 but a different y value. And so we're expecting a positive and a negative value for when we solve for p. And from context, we're going to look at the negative value. Okay. So what we're going to do is, when I substitute -10 here, it becomes -10 plus 4 all squared plus p minus 2 all squared equals 61. -10 plus 4 is -6 all squared plus p minus 2 squared equals 61. So -6 all squared is 36. Okay, plus p minus 2 all squared equals 61. Then if I subtract 36 on both sides, 61 minus 36 is 25. And then if I square root both sides, I'm going to get plus or minus 5. So therefore, I've got two solutions. P minus 2 equals +5, or P minus 2 equals -5. So if I add 2 on both sides here, I'm going to get P equals 7. And if I add 2 on both sides here, I'm going to get P equals -3. But again, we were expecting that. Here's going to be 7, and here's going to be -3. So this is the P value that we are looking for, -3, based on the context of the question. All right, so just keep that in mind. Whenever you're solving things algebraically, you could have various solutions. But based on the geometrical context of the question, some of those solutions will be what we call extraneous, which is just a fancy mathematical word for saying that yes, it makes sense algebraically, but no, it doesn't make sense within the context of the question. Because 7 didn't make sense because that is this point up here. Okay, and then lastly, determine the equation of the tangent at the point Q. So we know that that's -3 now. So again, if I draw a tangent line at that point, let's make some observations. We expect the gradient to be negative, and you can see it going all the way down here. So we expect the c value, the y-intercept, to be negative as well. So first of all, let's get the gradient of the radius, which again we can work out here. So it's going to be a positive gradient, and it goes 6 across and it goes 5 up. Okay, so the gradient of the radius is 5/6. So therefore, the gradient of the tangent line is the negative reciprocal, so -6/5. Because when you multiply these two together, you get -1. All right, so now that we've got that, we've got the equation to be y equals negative 6 over 5x plus c. And then we can substitute the point of contact q, which was negative 10, negative 3. And then I get negative 3 equals negative 6 over 5 times negative 10 plus c. So the negative and negatives become positive, and 10 divided by 5 is 2, 6 divided by 2 is 3, plus c. Okay, and then if I subtract 3 on both sides, I get c is equal to negative 6. So let's just double check that to make sure that that makes sense. Okay, so negative 10 divided by, okay, so already there's an arithmetic mistake, and those are always bound to happen, right? Because I divided twice when I shouldn't have. So let's do this properly now. Negative 10 divided by 5 is negative 2. And then negative 6 times negative 2 is positive 12. That's looking much better. Okay, and then if I subtract 12 on both sides, I get c equals negative 15. And that's what we expected. The moment I saw c equals negative 3, I thought something's wrong here, because here's negative 3 here, and my y value is all the way down there. So that's why you can catch it. That's why analytical geometry is so powerful, because you can see the geometry in it, and you can immediately tell if there's something off in the algebra, and vice versa. Okay, so therefore the equation of the tangent line is given by negative 6 over 5x minus 15. And that's what we've come to expect based on this diagram as well. Okay, so that's how we will do these types of questions. I'll see you in the next one.